I'm going to be explaining type 2 of binary ionic compounds. For this type, you're going to be incorporating the transition metals, which are located in 3 through 12 groups, and also tin and lead. So for this, I'm going to be explaining the formulas first and then the nomenclature. So for the formulas, for example, you could be given an atom iron, 2 chloride. Now, notice the Roman numeral given after iron. What this says is that the charge for iron would be 2. And the reason why it's saying this is because the transition metals don't have a charge, so they're given to they're giving you one in the problem, but you will have to end up finding it later on. So in this case, you're going to write out the symbols. So Fe and Cl. And since the charge for iron is already given to you, you're just going to write 2. And for chloride, you're going to look at your periodic table, and it's just going to give you -1. And the negative doesn't affect the formula at all. So the method that we're going to be using for this is you're going to be using the cross method, which just means you're switching the charges, and the charges are going to be given as a subscript. So to show this, the chlorine charge would go to iron, and the iron charge would go to chlorine. So you're going to write this out as Fe, and the 1 wouldn't be shown since there's only one of it. And you would write Cl for chlorine, and the subscript would go down here, and that would be 2. And another thing to keep in mind is that if you have the same charges, so if chlorine would also have a charge of 2, they would cancel out, and you would not write a subscript, so it would just be FeCl. And another thing is that if it gives you a situation where you would be able to simplify it, then you would do that. So for example, if the 2 were a 4 and the -1 were a 2, you divide both of them by 2, and this would end up being a 2 and this would be a 1. So that would be your answer for this scenario. Now, another scenario that you could do is, for example, let's see, we could do tin sulfide. So tin, 2, sulfide. So tin, if you look at it on the periodic table, its symbol is Sn, and it gives you a charge of 2. And sulfide or sulfur has a charge of 2, so you would also write that here. Now see, in this case, since their charges are the same, they would be able to cancel out, so your answer would just be SNS. Now, for the nomenclature, it can get a little bit tricky, but it's pretty simple once you get the hang of it. So it would give you a formula, like for example, PB3N2. And to start us off, we can just write out the names of the elements, which this is lead, and leave parentheses for the Roman numerals. The Roman numerals, again, are the charge of the element, and this is nitrogen, or nitride. So in order to do this, you're going to look at the charge that is given to the second element, since remember the first element is a transition metal, so it does not have a charge. So for nitrogen, if you look on your periodic table, it has a charge of 3-. Now, this is where you find the charge of lead. So you're going to multiply the subscript and the charge together and divide them by the subscript that's given to you in the transition metal. So 2 times 3 is 6, and if you divide 6 by this 3, it would give you 2, so 2 would be written as a Roman numeral, and this would be your answer. And to do another example, we can do, let's do lead or PbO2. So again, to write our elements, it would just be lead, parentheses, oxide, and finding the charge for oxygen, it's 2 negative, and you would just multiply these together, it gives you 4, and since lead does not have a subscript, it would just be considered as 1, and 2 times 2 is 4, so you would just write out 4 as a Roman numeral, and that would be your answer. So remember, for the formula, you cross them and you simplify if needed, and for the nomenclature, you multiply and divide. And that's basically it.